Capacitors and DC circuits. What is a capacitor? A capacitor is an electrical component that draws energy from a battery and also stores the energy. Inside, the terminals are connected to two metal plates that are separated by a non-conducting substance. When activated, a capacitor quickly releases electricity in a tiny fraction of a second. The ability of a capacitor to store charge is known as capacitance, denoted by C and measured in farads. What is a DC, also known as direct current? By definition, it is a closed path in which the direct current flows in. Also, when electrons move in one direction only, there are two main types of circuits, series and parallel circuits. Capacitors in a DC circuit are not deemed as important as it is impossible for a steady current to flow across a capacitor. Capacitance in series circuits. To find the total series capacitance, each value is put over 1 and the sum is taken and then put over 1 again. In this example here, we have values of 2, 4, and 6 farads. When these values are plugged into the formula, we get a total capacitance value of 1.091 farads. Capacitors in parallel circuits. Similarly, to find the total parallel capacitance, the sum of all capacitance is taken. In this example, we have values of 8, 4, and 2 farads. When these values are added together, we get a total capacitance value of 14 farads. Transient phase, also known as charging phase. The term time constant allows us to calculate the amount of time needed to charge a capacitor from an initial voltage of 0. To calculate this value, the resistance is multiplied by the capacitance. After 5 time constants, the capacitor is fully charged and also considered to be in a steady state. This phase is also considered an open circuit. As charge is being stored in the capacitor, voltage across the capacitor rises, making the voltage drop across the resistor, while current in the circuit drops. This is made evident in the graph towards the right. Formulas to calculate current and volume in the charging phase has been shown. Discharging phase. As charge is flowing at the capacitor, voltage across capacitor drops, resulting in the voltage dropping across the resistor, and thus current also drops until capacitor has been fully discharged. This phase is considered a short circuit. Formulas to find voltage and current in the discharge phase has also been shown.